Hi everyone. In the last video I checked these out, I've shown them to you, and I looked at their voltages, and we could see that certain ones were better than others in that regard. I mean, these ones in particular, wasn't there one of these it was higher voltage? Oh, then again that one would be, because it's a bigger thing, but one of these here, 4.72, was bigger than this one. Bigger voltage, and in fact it was bigger than this one as well, even though it's slightly bigger. But anyway, in this video I want to go through the amount of current that I can pull. You know, I know it's only a small amount of light, but it would be a good indicator of how good these things actually are. So I'm going to get this thing back, and one by one I'm going to test the amount of current that we can draw based on this light here. So let's get ourselves set up again. So we need to change this to amps. Change this to amps now. How much am I going to be able to draw roughly? Well, these are going to be only a few watts probably, so 200 milliamps. I'm not expecting to draw more than that. So I'll get this thing back, so we can see. Okay, so let's try this one. Negative on there. Now hang on a minute, I've got to be careful what I'm doing here. Now there's not going to be a huge amount of current, so we should be okay. How much current can it draw? Nothing. Surely that's not right. Hang on. We've got the plus, we've got the minus. Nothing. How can it be nothing? Nothing at all. No amps. Surely not. Alright, well hang on then. Take that out of there, put it in here. Oh, that's strange. Okay, so 200 milliamps max. That didn't work for some reason. So 200 milliamps max, and what was it drawing? It's saying, well, what exactly is that saying? 1 milliamp. 1 milliamp, is that right? Wow, that's low. 1 milliamp. But it is only a small amount of light, so let's just put this back up here. 3.3 milliamps. That's quite pathetic, but anyway. Yeah, let's do the test fair again. So 1 milliamp, fair enough. 1 milliamp. Now, like I said, it is very poor light, so what more can you expect? 1 milliamp. So put that over there, and let's move on to the next one. Now, these ones that are in parallel are obviously going to be able to draw more amperage. So, excuse me. Okay. Wow. Let's connect these up again and see what happens. So, okay. So, are we alright there? So 2.3 milliamps. Okay, 2.3 milliamps, that makes sense. Let's go up here. This will be 6, I suppose. Oh, 7. But to keep the test fair, 2.3 milliamps. Okay. 2.3 milliamps. 2.3 ma. Next one. Minus and plus. I've just done that in reverse there, not that it matters. And minus. These things are so slippy. Okay, and what are we having here? What's happening here? 0.9. Now if those wires weren't in the way, it might be 1. Let's have a quick look. So we've got 0.9 milliamps on this one. 0.9 mA. 0.9. And what have we got next? Let's go for this one. Now this one will also be 0.9, I'm pretty sure, but let's check just to be fair. 0.9. Have we got a good connection now? No, it looks like we haven't. Hang on a minute. If I just take this thing off, this black thing. We're after 0.9 now. I think I can break that off. There we go. 0.9 is what we expect. So let's put it on there. 0.9. 0.9 mA. Now of course under a lot more light this would be a bit more well, you'd be able to draw a lot more current. Now let's try this one. Okay, 5.7, but this is one of the, this looks like it's in parallel again, so I expect to receive, what do I expect to receive from this one? I expect to receive 2 milliamps or so. So let's put the minus on and the plus. Yeah, 2 milliamps. I expect to receive. What's going on here? There's nothing. Why is there nothing? Got the minus on properly. Is the plus on properly? Yeah, it should be. And there we go. 1.3. Wow, 1.3. That's not very good, is it? 1.3. What is it up here? 4. Wasn't the one that was really impressive before? It was this one, yeah, this one. This one could draw 2.3. Lower voltage as well, so that's very interesting. Anyway, so this one is, what would we say it was? 1.3. Let's take this off. Now these will act different in different, just one second. This will act different in different, what am I trying to say? Intensities of light. Certain ones are more efficient at lower levels of light and certain ones are more efficient at higher levels of light. It's just an interesting thing. But anyway, I'm just playing about at the moment. So we've got one of those two, and we've got the final one, which is this one. So here we've got the minus on there and the plus on here. Now what do I expect here? These are in series with just one bank, if you like. So this will probably be 1 milliamp in this light. So let's see, and it says 1.3. okay, that's a good result. 1.3. 1.3 mA. 1.3 mA. Okay, so that's all of the results done under this light. Now let's go through them and see what we can do. So what have I learnt with these tests? Well, I haven't learnt a great deal as such, but we've got a rough idea of the voltage and current that can be drawn at these light levels. Now this voltage here, I can't remember the exact name. I think it's like open voltage or something like that. Solar panels have two ratings. They have open voltage and another type of voltage, which is like the voltage under load or something like that, or initially under load. I can't remember the exact detail. But yeah. But it does give us a rough idea of what's what. So 1 milliamp for this one. Now if this was under full irradiance, or whatever the word is, I think they're rated at a certain amount of irradiance. I think it might be, well, it'll be like 1,000 lumens on it or something like that, or 1,000 lux or whatever. I can't remember exactly how it works, but they'll be rated to that. So this will be rated to a certain voltage at a certain amount of light and with a certain amount of current. So yeah, it's just an interesting test, I suppose. But yeah, I have an idea now of what sort of voltages I can get from these. Like this one, for example. Well, in fact, even this one, 4.72. I mean, I'm not exactly sure, but under load that could be something like 4.2 volts, and if it was like maximum of 4.2 or thereabouts, then you could actually charge a lithium-ion cell, because they charge maximum at 4.2 volts. So if this is 4.2 volts, or it can be 4.2 volts under a decent amount of light, then potentially that could charge a cell. And these ones, you know, that's about 4 or 5 on that. This one 5.28, so you know it's actually going to be more than that probably under a decent amount of light. And under a decent amount of light, you could probably have a voltage regulator or something like that, and power an Arduino or something. You know, it just depends. And what else we got here? 4.55 again. Even this, it's probably actually a 5 volt panel. It's probably intended to power 5 volt devices. I'm not too sure. This one, what was this one again? 5.7. So is that, maybe that's a 6 or 7 volt module or something? And this one, 9.2. So maybe that's a 12 volt solar panel. I'm not too sure. You know, intended to power 12 volt devices. Like maybe I could connect it to a car battery and maybe charge it, depending on the light. I'm not too sure. But yeah, I just thought I'd investigate these and show you my findings anyway. I know it's not massively interesting, but it's just an interesting few tests that I wanted to do. Anyway, thanks for watching. Bye.